Alright, so the following is mostly right. I'm going to use FA 2013, page 78 to do this. You're going to make collagen and you're going to make it inside fibroblasts, and when you first translate it and make something out, the rough product is actually called pre-pro collagen. So after you've made it in your rough ER, why are you making the rough ER? Because you're going to dump it out, you're going to exocytose it, and so you're going to need it to make it in some sort of membrane. After you made it, you're going to try to process it. The first thing you're going to do is hydroxylate it, still in the rough ER, and you're going to need vitamin C to hydroxylate. So now if you have like some sort of vitamin C deficiency, that's going to screw up your collagen synthesis, and you're going to end up with something called scurvy. So after you've hydroxylated, you're going to try to glycosylate, and you're still doing this in the rough ER, and you're going to make a product called pro collagen. Now if you screw this up, this glycosylating up, you're going to end up with something called osteogenesis imperfecta, and you can't make pro-collagen. Alright, so now that you made your pro-collagen, you're going to dump it out, you're going to exocytose it. Now you're still not done because you're going to try to process it some more. Why are you still trying to process it? Well, one, because you need to make it into bigger structures, but two, because the collagen that you dumped out is soluble. Now if it was insoluble inside the cell, and while you're dumping it out, that's kind of weird, right? You don't want something insoluble that's just bulky and not easy to work with, but once it's outside, you do want it to be insoluble and, with a lot of integrity and whatnot. So to do that, you're going to trim off the disulfide ends of the molecule that you put out, and once you do that, that magically makes it insoluble. I feel like I'm confused, soluble and insoluble. Anyways, now, once you trim it off, you made it insoluble, you've made something called tropocollagen. Now, you're still not done because you need to put these together into something bigger like fibrils and whatever you want to make. To cross-link it, you're going to need this enzyme called lysyl oxidase, and that's going to do some magic with the lysine that you hydroxylated earlier in this step, and do something, I don't know, it's going to do something. And you're going to need copper to make that magic happen. So lysyl oxidase needs copper 2+. Don't know why that's important, but it's an FA, so I guess that's important now. Okay, so once you cross-link it, then you make it into fibrils, and then you're happy-dappy. But if you can't do that, if you can't cross-link it, now you're kind of screwed, and you're going to end up with Ehlers-Danlos. So this is, yeah, that's what's going to happen. I think we're done. Maybe I'll talk about elastin next, but I think we're done with collagen.